Okay, Unit 3, Chapter 7, looking at trigonometric applications. The biggest thing in this whole unit is law of sines, law of cosines, and vectors. Now, you'll notice here, this giant thing, this is actually the law of sines. This right here is the law of cosines. And you'll notice that this triangle down here, it's not a right triangle. Okay, so when we start these notes here, okay, you'll notice that what we want to do is we want to solve, okay, a triangle. Now, if you read this definition, it says solving a triangle involves finding all the lengths of the sides as well as all the angle measures. Okay, so in terms of 2a, we are given capital A is equal to 90 degrees, okay? Little a is 5, and little b is 3. Now, all your capital letters will be angles. All your lowercase letters will be sides. So we have a triangle here where angle A is 90 degrees. Okay, so this would be my A. I'm going to go ahead and draw the rest of this stuff in here. I'm going to have some sort of B and some sort of C. Now, if I have those two set up that way, my B, the little b, should be over here. Okay? The little a should be across from here. What does that force little c over here to be? Okay? Well, little c then has to be, well, 3, 4, 5 triangle, right? This is a right triangle. So this would be 4. And then the situation would be to what is the angle measures here and here, okay? Now, with this particular equation, with this particular triangle, it's not as easy to find out what B is and what C is based on what we have. But because this is a right triangle, I could use the sine of C is equal to 4 divided by 5. Okay, and by utilizing my calculator appropriately, I can say C is equal to the sine inverse of 4/5. Okay, and make sure we find that in degrees. Okay, again, make sure we find that in degrees. We can also do the same thing for finding B. I can look at the sine of B. This angle here is equivalent to the opposite, which is 3 over 5 hypotenuse. Okay, that means that my b value is going to be equal to sine inverse of 3/5, and again we're going to find out what that is utilizing degrees. I'm going to do this over here in my calculator very quickly. Sine inverse of 4 divided by 5. It's going to give me my degrees. Do I actually have it in? Check my mode here, make sure it's in degrees, and it is in degree mode. So I have approximately 4 sine of 4/5, sine inverse of 4/5 right here. That's approximately equal to 53 degrees. And because it doesn't tell me, I am going to round to the nearest degree because it doesn't tell me, and all my measurements are whole numbers. Okay, this one down here, that means it's going to be 47 degrees, give or take, because those two added together plus the 90 should be 180 in total. So that's solving a triangle. Again, finding all the sides and all the angles. Now this one was easy to do because this was a right triangle. Okay. The situation that I have is, what if I'm given something that's not a right triangle? Okay, what can I do? What can I use, and how can I solve it? Well, that's where we come in with law of sines. Okay, law of sines is the statement that if I have a side divided by the sine of the angle is equivalent to the other side B divided by the sine of the opposite angle. Again, this thing right here is law of sines. Now, it gives us a comparison between a side and its angle and another side and its angle. So I could use just A sine of A is equal to C sine of C. I could just use those two. I could use those two. Whatever's necessary for whatever I'm given. Okay, so let's go ahead and look at 5A. With 5A, I'm given A is equal to 42 degrees. B is equal to 63 degrees, and then little c is equal to 18. Okay, so what I'm going to do here, I'm going to draw a triangle. I'm going to always, 100% of the time, draw a triangle. Now, personally, I don't really care if these angles are appropriate. Okay, if they match up the best. Okay, it really doesn't matter in certain circumstances. Okay, so what I'm going to do here is I'm going to go ahead and say, well, I have A and B. I should have an angle C that I'm missing. okay? And then I have my side C. I'm missing my little a and my little b. Those are the pieces I'm missing. I'm always looking for, in this case, 3 pieces for every triangle, okay? Because they'll give me 3, I'll be able to solve for the other 3. So I'm going to draw a triangle here with, this is angle A plus angle B plus angle C, all added up, okay, should give me 180. So that means I have 42 and 63. That's going to be 105. That means my remaining angle has to be 75. Okay, that's part of my solution, 75 degrees for angle C. Okay, so in theory, when I draw this triangle, I should draw that angle the biggest, that angle the next biggest, and then that one the smallest. I really don't care. Okay, it really doesn't matter. I'm going to call this C. Okay, I'm going to call this A and this B, okay? So this is going to be 42 degrees, and this is going to be 63 degrees, okay? Across from C, I have C equals 18. Now I just have to find out what A is down here and B is over here. Now the reason why this is A is because it's opposite the angle A. The reason why this side is B is because it's opposite the angle B. Now with this thing here, all I have to do is utilize that rule being the law of sines. I have little a over the sine of 42 is supposed to be equal to little c over the sine of 75. Well, I should probably plug in what c is. C is really 18. Hey, look, there is only one variable in this entire situation, and that's a. Okay? So, with that, I will go ahead and solve for a. I'm going to get a by itself, multiplying both sides by sine of 42. This is 18 sine of 42 divided by the sine of 75. Again, making sure my calculator is in degree mode before I do anything, okay? Or just making sure I plug in the sine of 42 degrees and the sine of 75 degrees appropriately. I'm going to have 18 times the sine of 42 degrees divided by the sine of 75 degrees, okay? There. Okay, and that's going to give me a value of approximately 12.46922 ... Okay. What do I want to round this to? Well, the problem itself doesn't tell me. It just says solve the triangle, okay? If it doesn't tell me what to round to, I'm going to round, okay, to the value that is provided for that length or angle. For this length, I'm provided 18, no decimal places. So I'm going to round this to 12, no decimal places. Okay, so that's A. A is equal to 12. Okay. Now I got to find B. Okay, I have to find the last piece, which is B. Now, when I'm doing this, I will not use this information right here. I'm going to use this information again. Why? Because it is consistent, it is accurate, and it is unchanged. Okay? If I try and plug in a 12 here, that value is rounded. It's not perfect. If I use a rounded value to find another value, everything's going to be all cockeyed. Okay? So what I want to do here is 18 over sine of 75 degrees is equal to, and I'm going to go ahead and use for B now, B on top, sine of 63 degrees. Okay? Solving this time for B. B is equal to 18 sine of 63 degrees divided by the sine of 75 degrees. And then I go ahead and plug that into my calculator all over again. So 18 sine of 63, and I divide it by the sine of 75. And I get approximately that this is 16.60388 ... Remembering, I want to round to the nearest whole number, so this is going to be approximately 17. So my B value is 17. I have the 3 remaining pieces. In total, I should have 6 pieces. Okay, because there are 6 pieces to a triangle, 3 angles and 3 sides. This triangle is now solved. What we're going to do is we're going to move on to example 6, or what we would call the ambiguous case, okay, in the next video.